All right, so this time we've got sulfuric acid and we've got potassium hydroxide. So just a little bit different, but we're going to start out the same with our net ionic equation. We've got H2SO4. We've got potassium hydroxide. And then over here, my H pluses will end up with my OH minuses to give me H2O. My potassium will end up with sulfate. And remember that potassium is +1, sulfate is -2. So the formula for that is K2SO4. And then I need to balance. I hope you didn't forget to do that. Because right here I have 2 potassiums, so I need 2 KOHs. I have 2 hydrogens over here and 2 hydroxides, so I need 2 H2Os. And that should have everything balanced out. If that gave you some trouble and you couldn't do that on your own, like forgetting to do K2SO4, remember that that's why we did the complete ionic equation, and a lot of you guys liked to write this out with all of the ions before you went back and did the products up here, and that's totally a reasonable thing for you to do. I've already done it, so I'm just gonna write it all out. And in good fashion, I'm running out of room. I don't think any of us truly miss writing out all these equations. Okay, then I've got to look for my spectators. They're the potassium and the sulfate. And notice they are balanced. 2 potassium ions, 2 potassium ions, 1 sulfate, 1 sulfate. And so my ionic equation ends up being essentially double what it was before, but of course, since this is 2, 2, and 2, you could reduce it to just be 1. So that's pretty much all that we're doing. Same net ionic equation that we had before. And the whole point of a neutralization is moles of acid, or moles of H plus equal moles of OH minus. So I want moles of this equal moles of this always for neutralization. Okay, so now looking at this, I've got concentration of my acid, and I've got volume and concentration of my KOH up there. So I'm going to start with my KOH because I know more about it. I've got its volume and its concentration. So now I'm going to go through and I'm going to start with my 125 milliliters. If you're someone that tried to start with the concentration instead, you probably found that it was a little difficult for you to keep going with it. Because when you're doing stoichiometry, the units just don't cancel as well as you want them to. So always start out with the volume and use the molarity to convert the moles. That's a pretty solid rule for this unit. When we first learned stoichiometry, you learned quickly that moles are the smartest place to go, always. Because once you convert to moles, you have more options. And that stands true pretty much always in chemistry. Okay, so for every 1 liter, we have 1,000 milliliters. And for every 1 liter, we have 0.050 moles of KOH. And for every 1 mole of KOH, we have 1 mole of OH minus. And that right there, to 2 sig figs from this right here, from the problem, it's going to be 0.0063. Okay, so I found my moles of hydroxide, which means that I now know my moles of what? H plus. I have to have that many moles of H plus. But this is where it gets a little bit different, because is there 1 mole of H plus for every 1 mole of H2SO4? No, there's 2 H pluses for every H2SO4. So my stoichiometry gets a little bit different here. And if you forget that, you'll end up with the wrong answer. And that's why I do this step. I know it wasn't very helpful up here in this problem because it was 1-to-1 all the way through, but when it's not, it makes a very big deal, okay? And after I have my moles of H2SO4, I can use my concentration. I know there's that many moles per 1 liter, and I'll end up with 0.032 liters. Okay, so big picture, what I found out here is if I have, and this is honestly very, very legitimate all the time, I do this in labs pretty much constantly. If we were in a traditional classroom setting, I would be doing it all the time in this acid-base unit because I make up using my dilutions from over on this side, I make up like a liter of hydrochloric acid or something for you guys to use in a lab. But do you think that you're going to use every drop of that 1 liter of strong acid? Probably not. So I take the volume that is left over and I can calculate how much of a base that I need to put into it in order to neutralize it so that I can put it down the sink. So this is a very, very real application of what's going on here. I use it all the time. We will use it all the time, especially coming up in the next unit, okay? So this is definitely something that you should practice. And there are now some practice problems from your worksheet that you can work on. I don't remember the numbers right now off the top of my head, but I know I'm going to put it on the update, okay? So shoot me a message in the discussion board if you have any questions, all right?